Dear students, welcome to the next lecture in this course on signals and systems. So we were discussing about the convolution operation, and we have seen some problems based on this. So in just the continuation of that, we'll try to solve some more problems on convolution. Now let us look at this problem where xt is given as 1 in between 0 and 1, and it is given as 0 at all the other places. Okay, and the impulse response, which is ht, it is given as x of t by alpha, where alpha is in between 0 and 1. Okay, so the question is that you have to determine and sketch the convolution of these two signals, that is xt and ht. Okay, so this is your problem statement. Now the procedure will be the same as we had done in some past problems as well. There will be a 3-step procedure. So at the starting you can just write the definition of the convolution, which you know, that means the mathematical expression, that is convolution is represented as yt, which is equal to xt convolution ht, and it is written as x tau h of t minus tau d tau. Okay, so you can just start your solution by step 1, which is to write the equations and draw sketches for xt and ht. Okay, so xt and ht both are given in the problem itself. You can again just repeat those here. So this is xt, which is given in the problem, and similarly ht is also given as xt by alpha, which will be equal to 1 if this t by alpha is in between 0 and 1, which means that t will be in between 0 and alpha, and it will be 0 at the other places. So if you just plot these two signals, so this will be 1 in between 0 and 1. This is your signal xt. Okay, and similarly if you plot ht, so ht is 1 in between 0 and alpha, isn't it? So this is how the first step is completed. Now you move to the second step of this problem. Now in the second step, what you have to do is you have to write the equations and the draw sketches for x tau and h t minus tau. So all this procedure have already been explained for the last problem. Okay, so I am just repeating that procedure again for this problem. So x tau will be equal to this 1. Okay, and obviously in this writing this x tau, you just have to replace the variable t with tau, and now in writing the expression for ht minus tau, so you can do it in this way, and this is equivalent to this. Okay, that means the ht minus tau will be equal to 1 if tau is in between t minus alpha to t. Okay, so again if you just plot these two signals, so this x tau will be simple, that if tau is in between 0 and 1, this signal is 1. So this is simple, and you can draw ht minus tau in this way. So that will be t minus alpha up to this point t. Okay, this is your origin. So you can also obtain this waveform of ht minus tau from ht. Okay, so that thing has already been explained in the last problem, but still I will explain it again, that in obtaining ht minus tau from ht, you first have to just replace the variable with tau, then you have to do some shifting operation, shifted by this factor t, and then after shifting you have to perform the time reversal operation, so that it will become h of minus tau plus t. So this h of minus tau plus t will be equal to h of t minus tau. Okay, so in the waveform of ht, if you perform these operations, that is this is shifting. Okay, this is shifting, and this is, you can say, time reversal or time reflection, whatever you may call it. So just by doing these two operations, you can obtain the ht minus tau waveform, which will be this. Okay, now you move to the third step of this problem. Now in the third step, what you have to do is to perform the integrations and find yt, that is the convolution, for all the values of t. Okay, so in this third step, obviously you have to take different cases for it. So first case can be taken as t less than 0. So for t less than 0, you have to draw the waveforms for x tau and h t minus tau. So if you represent it in the same xy plane, so if this is the case, let me draw it with a different color. Okay, so your this waveform is ht minus tau, whereas your this waveform is x tau. Okay, the amplitude is same. This means obviously this will be 0 and 1, and this point will be t, and this point will be t minus alpha. Okay, so just in the waveform of this ht minus tau, you can visualize it that if this point t, which is this point, if this point t is less than 0, that means this ht minus tau waveform will be towards the left hand side of this. Okay, obviously this will depend on this value of t. So this condition is depicted in this sketch. So from here you can see that these two signals, that is this x tau and ht minus tau, they do not overlap, and since they do not overlap, that means the convolution of these two signals will be 0. Okay, so the convolution of these two signals for this particular case will be equal to 0. Next, you consider the second case in which this t is greater than equal to 0 and this t minus alpha is less than 0. Okay, so that will just mean that this t is in between 0 and alpha. So again in that waveform you can see that what will happen if t is greater than 0 and t minus alpha is less than 0. Okay, so in that case, if I just represent it with the help of the waveform, obviously this xt will remain same. Okay, this is the xt waveform. Sorry, this is x tau waveform. Okay, now h t minus tau, I will show it with a different color. So this will be ht minus tau. So this waveform, which is shown by this blue, this will be h of t minus tau. Okay, so this point will be t, whereas this point will be t minus alpha. So t minus alpha is less than 0, whereas t is greater than equal to 0. So now for this particular case you can see that there is some overlapping between the two signals. So this is the area of overlapping, you can say, that is the period up to which these two signals are overlapping. So convolution have to be calculated for this period. Okay, so you can simply calculate the convolution for these two, because the overlapping period is from 0 to t, so that is why the limit will be from 0 to t. Amplitude is 1 for both signals. Okay, d tau, so that will be equal to t if t is in between 0 to alpha. Next you move to the third case, where this t minus alpha is greater than equal to 0 and t is less than equal to 1, which can be simplified to t is in between alpha and 1. Okay, so again you have to plot both the signals. So obviously this x tau will remain same. Okay, this is x tau, and now what will be this ht minus tau. So you can see that t minus alpha is greater than equal to 0, but t is less than equal to 1. So somewhere in between this x tau, h t minus tau will come. So you can represent it by this waveform. So this inner waveform will be ht minus tau, okay, and this point will be t minus alpha, and this point will be equal to t, okay, and obviously this is 0 and this point is 1, okay. So now you can see that the period of overlapping of these two signals is this period, okay. So for this period, that is the overlapping period, which can be written in this manner, okay. So the convolution, that is yt, so you just have to put the limits according to the period of overlapping. So that will be equal to alpha, okay. So t is in between alpha and 1. Similarly, you move to the next case, that is t minus alpha is less than 1 and t is greater than 1, which can be simplified to this one, okay. Now again you plot the graph. So if this is xt from 0 to 1, this is 1, this is your x tau, okay. So now if this t minus tau is less than 1 but t is greater than 1, so the waveform of ht minus tau can be represented by this, okay, where this will become t and this is t minus alpha, okay, and this portion is called the period of overlapping. So again you can just calculate the convolution, and the limits will be again according to the period of overlapping. Now here the period of overlapping is between t minus alpha to 1, that is why the limits are put as t minus alpha to 1, okay. So 1 d tau, that will be equal to 1 minus t plus alpha, okay, for time limits in between 1 to alpha plus 1, okay. And then the last case, that is case 5th, if t minus alpha is greater than 1, that means that t is greater than alpha plus 1. So in that case the waveforms are represented like this, okay. This will be your h t minus tau, this is t minus alpha, this is t, and this waveform is xt, this is 1, this is 0, this is 1. So this t minus alpha is greater than 1, that means the signal is towards the right side of this x tau. So in this case you can see that there is no overlapping in between these two signals, and since there is no overlapping, you can directly write that the convolution for this part will be equal to 0. Okay, so whatever you have got in this case 1 to 5, you can just compile it at one place. So that will be equal to 0 for t less than 0, t for when t is between 0 and alpha, alpha when this t is in between alpha and 1, then 1 minus t plus alpha if t is in between 1 and alpha plus 1, and finally again 0 if t is greater than alpha plus 1. Okay, so this is the overall answer, you can say, for this problem. So if you have to you can also represent it with the waveform. If you have to draw, if it has been asked in the problem that draw the convolution, then after obtaining this final answer you have to draw the waveform for it also. So this is simple, just you can follow whatever functions are given for different intervals. Okay, so just based on that you can draw this. So this waveform will be something like this. So this will be alpha, this point will also be alpha. Okay, so from 0 to alpha the signal is given as t, and this point will be 1 plus alpha. Okay, and this will be 1. So this is your final answer for this problem. Okay, now next we consider one more problem that will be slightly easy as compared to this one. Now in this problem the functions which are given to you in between -1 and 1 it is given as 1, and 0 at other points, and the function ht is given as del t plus 1 plus twice of del t plus 2. Okay, again the question is same, that determine and sketch the convolution of these two signals. Okay, that is of xt and ht. Now at the end of the previous lecture, if you remember, I discussed two important results regarding the convolution. Specifically those two results were this xt convolution with delta t minus t naught will be equal to xt minus t naught, and xt convolution del t plus t naught will be equal to x of t plus t naught. Okay, so these two results were discussed at the end of the last lecture. so you can just see that lecture as well. So in this problem we will use these standard results to solve the problem. Now yt, which is the convolution, again it can be represented as xt convolution ht. Okay, this is xt convolution, and then in place of this ht, that is impulse response, you can write the impulse response which is given in the problem. So this will be equal to xt convolution del t plus 1 plus xt convolution twice of del t plus 2. So obviously you are using the properties of convolution also here. If you remember some of the properties that were discussed in the last lecture, so those properties are also being used here. So this yt, now you can see that xt convolution of del t plus 1, that means if you use this second standard result xt convolution del t plus 1, then it will become x of t plus 1, and similarly here xt convolution del t plus 2, it will become xt plus 2, and this 2 will all obviously be outside. Okay, so the result I will write as xt plus 1 plus twice of xt plus 2. So this is your expression, mathematical expression of the final result. So if you have to plot it, you can very easily plot. First you have to plot the waveform for xt, which is for which the function is already given in the problem. It is 1 in between -1 and 1, so -1 to 1 it is given as 1. So this is your xt waveform. Okay, and similarly ht is also given to you. So ht is basically there are two impulses which are located at -1 and -2. So amplitude of this impulse is 1, amplitude of this impulse is 2. So since the answer is x of t plus 1 plus twice of x t plus 2, so just by utilizing this xt waveform you can obtain the waveform of yt, isn't it? So you just have to perform some basic operations of shifting, and you can very easily get the output waveform. So I will draw the output waveform here. So let me just make some points. This is 1, this is 2, and this is 3. Okay, so this is -1, this is -2, this is -3. So from -3 it will start, and it will go up to this -2, and then it will rise to this -3 up till this point. Okay, so this will be -3, this will be -2, oh sorry, this will be 2, this will be 3, its amplitude, this is -2, this is -1. So this waveform is actually your resultant or the answer for this problem. You can just try by using this xt waveform. Okay, so first you do first you obtain this part xt plus 1. Obviously this will be obtained by just shifting this towards the left side, and then you obtain the second part xt plus 2. Obviously this will be obtained by shifting this waveform by 2 units towards the left, and then whatever waveform you obtain, you just have to multiply its amplitude with 2. So when you obtain these two different parts, you just sum them up, you will get this final waveform. Okay, so in this way we have reached towards the end of this lecture, and there are some more problems which is to be solved, which will be taken up in the coming lectures. Thank you very much.